108 befriends Fezzik like a princess bride. 108, the number of degrees in the putrescence of our true-loved pentagon. All 5 corners are 108 degrees each. After hearing some interesting things about the number 108, and that it is considered sacred in geometry, I was soon fascinated by the fact that there are 108 moon diameters between Earth, hello lady, and the moon. That is just below the average distance to the moon, 238,857 miles. All this video is in miles, hours, days, and degrees because I have 6 fingers on my right hand. Also, the full numbers I found and calculated are in the description. I'm abridging here for better storytelling and leaving out the kissing, but all the carnal details are in the text below. Anyway, where was I? Ah yes, the faraway westerly sun's diameter is equal to 108 moon diameters, and the distance to the sun is 108 sun diameters. I thought to fetch some other things. The first one I thought to fetch was a pail of distance to the moon. As you wish. The average distance to the moon multiplied by 108 is the closest that Earth gets to any other planet. That planet is Venus. Hello, lady. These were just rough estimates, but as I delved into more calculations and tried to find more exact measurements, I found more surprises. It verged on becoming inconceivable. So, that last one was an average moon distance of 238,857 miles times 108. That's 25.7 million. And the average distance from the sun to Venus is 67.2 million. And the average distance from the sun to Earth is 92.9 million, making an average annual passing distance of that 25.7 million. Venus is Earth's closest planet. The farthest Venus gets from the sun and the closest that Earth gets to the sun would be 67.6 and 94.5. There's actually 5 zeros there. Seems strangely rounded off to be accurate, but never mind, I've worked miracles with far less. That's a max closest pass of 23.7 million divided by 108, and you get 219,000. Recently, the moon's perigee was 221,000 miles from Earth, making it the closest full moon in 69 years. So I assume in the eons of moon time, 219 is not too far-fetched. And because the moon continues to spin away from the Earth at about 1.5 inches per year, about how fast our fingernails grow, if you turn back the clock and add a little gravitational kick to the numbers from one extra planet in the line, it's almost safe to say that the 219 has occurred over the human species and possibly over a human civilization like Gilda. The closest average distance to Venus being 25.7 million multiplied by our unwasted, perfect 108 is 2.777 billion. This is somewhat more true of an astronomical unit of our home. The distance from the sun to its farthest planet, gaseous Neptune, ranges from 2.771 to 2.819 billion. So Neptune's gaseous distance lands right on this number using Neptune's gaseous average distance from the sun of 2.79 billion. And multiplying that by 108 gives us 301 billion miles, or 3,247 AU. The astronomical unit of doing it your way with the rock, the Earth. This 3247 AU lands out into the Oort cloud, and in the middle of the most comet-rich areas of the Oort cloud, in an area called the Hills cloud. It's a battle of wits in the hills because I'm not sure what are the closest comets that are said to have an orbital distance closest to this number of 3247, but I did find one immediately at the top of the search results, which it was found not by one in ROUS, but by amateur astronomer Yuji Hyakutake of Japan. It is Comet C1996b2, also known as Comet Hyakutake. On January 31st, 1996, he found it with 25 by 150 binoculars only 55 days before its closest approach. He discovered other comets as well. Hyakutaki's comet has a farthest distance of 3,500 AU. However, I was not sure to use this as a marker, so I multiplied the 3247 AU by 108, and I got 5.54 light years. One star is farther than this, but not for long. He's gaining on us. There are only a few stars this close to us, and the closest one to this marker is Barnard's star, fourth closest star to the Earth, which interestingly has unexplainable large fire spurts, flares, for such an old fire swamp, red dwarf. It's 7 to 12 billion years old. Many say it does have a large gravity anomaly like a sinking sand planet, but this is not conclusive, it seems. It is not visible without a telescope. It has the highest proper motion of any other star in the sky, meaning its apparent movement is more than any other star. There are very few stars that could be second best for this, as their proximity makes for their besting of opponents in apparent movement. However, at 10 arc seconds per year, it's like the Dread Pirate Roberts ship and all the other stars are at the wedding reception. It's twice as fast as the second place star. It is out at 5.96 light years away, and my sacred 108 placed a marker at 5.54 light years away. After a little reading, I learned that the star gets closer to Earth and brings us together at 3.75 light years in the year 11,800, which means it will go 2.21 light years relative to our sun in 9,779 years, and it will be at that 108 marker of 5.54 light years in the year 3,865. That is 1,843 years from now. I'd bet my life on it. While Barnard's star is sailing eel-infested ether, I decided to go back to Hyakutaki's comet and used it as a marker on the way to Barnard's star. 3,500 AU times 108 is 5.97 light years. Barnard's at 5.96 was at the distance of, that's moving 0.0142 light years. This is a humperdink of a coinkydink. It was there only 62 years ago, about right in between the 1957 and 1962 Sputnik and Yuri Gagarin were making history as the first satellite and the first human into space, right before the summer of love, or the summer of kissing. In the history of kisses, there have been 5 points that meet at 108 degrees.